Hey James, welcome back to another video of FAQ series. In this video, we are going to discuss the frequently asked BITSAT questions from the chapter of laws of motion. Now, those are new to this channel, let me tell you that FAQ series is a series wherein we discuss the frequently asked BITSAT questions over the last 15 years. Okay, we also discuss the topic weightage of each chapter. So if you have missed out the previous videos, do check them out. 200 subs, subscribe, and let's get to this video. So before we dive straight into the questions and practice a whole lot of them, let's briefly discuss the topic weightage and let's see which topic is more important as far as our BITSAT is concerned. Okay, so here I've divided this chapter into two parts. One is the actual laws of motion and the second part is circular motion. Okay, now laws of motion is again a very important topic, and yeah, please don't skip it. You can expect at least two questions surely in your BITSAT paper from this chapter, or I can say that two questions will be from laws of motion in the BITSAT paper that you are going to answer this year. Okay, that's a bold statement and I hope that will be the case. Okay, so let's see which topic has higher weightage in BITSAT. Now this weightage is made keeping in mind the BITSAT trend over the last 15 years. Okay, so this is what BITSAT is over the last 15 years. Okay, so let's come to the topics now. First topic, equilibrium. Now only one question was asked from this topic in the 15 years of consideration. Second topic is Newton's laws. Okay, now questions are not asked on first law and third law. Only questions are asked based on the second law, F net equals ma, sometimes straightforward, sometimes a bit conceptual. Okay, so three such questions were asked, okay, wherein you had to use F net equals ma. Okay, now third topic is constraint motion. Now again a very important topic, and this has to do with your pulleys. Okay, pulleys and other constraint motion wherein the motion of one object depends on the other. Okay, so that is what constraint motion is, right? We are going to practice questions, so don't worry, we'll get to the questions. Okay, now the fourth topic, which is a very important topic, the golden topic among all this, the most important among all this is pseudo force. Okay, you won't believe it, but yeah, that is the case. Over the last 15 years, questions from pseudo force has repeated more than the other questions. Okay, so pseudo force is an important topic for BITSAT, although you can do Newton's laws of motion without pseudo force, but again it makes the concept very simple, right? So pseudo force is important topic. Don't skip any of this topic. Okay, don't skip this chapter at all. This is a very bad idea. It is a very bad idea to skip this chapter. I'll tell you why, okay, in a while. Coming to our next topic is friction. Now friction is also an important topic. Okay, each of this is an important topic. You can see that the weightage is almost evenly spread, right? There is no biasing. This topic is not favored over there. You can see that almost the weightage is same throughout all the topics, right? So again, friction. Now one topic in friction itself is favored, which is the block over block type of questions. Okay, block over block type of questions are very much favorite of your BITSAT. That is what I will say, and that is what we are going to practice in a while. I think 2 out of these 3 questions which were asked were based on block over block. Okay, so yeah, block over block is an important topic in friction itself. Okay, now coming to variable mass systems, no questions were asked from this. Hopefully that's a very good thing. Okay, it's a little bit subtle topic. Okay, by the way, you can, this is the only topic you can skip. Okay, okay, that is what I will say. Other topics, please don't skip. Variable mass is the only one that I will allow you to skip. Okay, now the fourth thing, or whatever this number is, others. Okay, others basically means now this laws of motion forms your foundation for the upcoming chapters. Okay, now it is itself an important chapter in your 11th standard, so questions can be easily made in composition with this chapter, right? So the topics of other chapters can be mixed with this and questions can be built. Okay, so such type of questions are more to appear. Okay, this composition is very much seen in BITSAT. Okay, so composition type of questions wherein one topic from one chapter is mixed with other topic. Okay, so here the topics itself can be mixed with one another, and also the topics from this chapter can be mixed with some other chapter. That is why I was telling you that you should not skip anything, not even a single word from this chapter except variable mass. Okay, now coming to part B, it's circular motion. Okay, this is a small thing that you learn in this chapter. Again, the first thing you learn about is the basics of circular motion, right? So questions were asked from there, two questions. Okay, might be they had asked you for calculating the centripetal force given the mass and the velocity of the body. So straightforward questions basically. No questions were asked on uniform circular motion and non-uniform circular motion. Okay, uh, questions were asked based on applications of circular motion. Now what is this? This is basically banking of road, then turning around a road, a circular road without skidding or things like that. Okay, we'll come to the questions. And finally, vertical circular motion, my favorite topic, but no questions were asked from this. So yeah, let's get to the questions now. This was the weightage over the last 15 years for BITSAT. So topic number 1, equilibrium. Okay, so let's get to the question straight. So question number 1, in this question you have an inclined plane. The angle of inclination is 30 degrees. On this you have placed a block of mass m. Now the frictional force on this block is also given. It is 10 newtons. Okay, you are supposed to determine the mass m of this block. And it is given that this system is in equilibrium. Now how to go about this? It is very straightforward question. From equilibrium you just have to resolve the forces and you just have to solve some equations, okay, and you'll have your answer. Now we'll resolve the forces. First of all, we can see that this frictional force will be along this direction, upward to the incline, right, because it is opposing the weight component in this direction along the incline, which is mg sine theta. Now this is a general result from your laws of motion, okay, from equilibrium specifically, that the weight component along the incline is mg sine theta and perpendicular to the incline is mg cos theta. Okay, if you didn't knew this, please remember it from now. Okay, it is very basic thing. Okay, so mg sine theta along the incline, mg cos theta perpendicular to the incline. Okay, now this mg cos theta will be balanced by the normal force, right? So n equals mg cos theta, these two are balanced, and from this we can find the value of m, if you see. Okay, so f equals mg sine theta, right? Because it is in equilibrium, that's why I am equating the forces along the incline and perpendicular to the incline. Okay, because it is in equilibrium, it is not moving. So this force equals this force equals this force, right? So f over here is 10, m we are supposed to find, g is 10, sine theta. Now theta over here is the angle of inclination, sine 30 half. So you can see 10 cancel, m equals 2 kgs. Okay, so option C, 2 kgs is the correct choice over here. Let's come to question number 2. Here you are given a block which is attached to a solid support. You apply some horizontal force on it so that it makes an angle of 45 degrees with the vertical. Okay, fine. The mass of this block is 10 kgs. Now when you apply this horizontal force, it comes to an angle of 45 degrees and it comes to equilibrium. Okay, and here you are supposed to find what is this horizontal force that you applied. Again, the very same thing, resolve and solve. Okay, so that is the basic idea of your equilibrium thing. Okay, so here if you see, I'll take this mass m over here. You can see that the force on this is this one, the tension force in the string, right? Here you also have a horizontal force F in this direction, right? And a force acting in the downward direction, which is its weight, right, mg. So if you see this angle which the tension, the string makes with the vertical is 45 degrees. So this angle over here, this over here, this angle, this small angle will be also 45 degrees. Okay, it's not small, it's 45 degrees. Okay, because these two are parallel lines if you see. Okay, these two are parallel lines and these two are alternate angles, right? So if this angle is 45 degrees, this will be also 45, right? Alternate angles, right? These are parallel lines. Okay, so this angle is 45, that is what I'm explaining. Okay, so now we can resolve this tension along this, right? Along the vertical and the horizontal, we can break it in two components, right? So if you see, adjacent to theta is cos theta, right? Adjacent to theta, t cos theta, so t into cos 45, which is root 2. Okay, so adjacent to theta, this component in the vertical direction, which is balancing the mg, right? And force over here, now force is balanced by t sine theta, right? T sine theta, opposite to theta. So opposite to theta is t sine theta. So that will be t into sine 45, again root 2, right? So 1 by root 2. Anyways, so yeah, due to that angle is 45, so we get the same value. Okay, so now just equate them because this is in equilibrium. So if you see, t root 2 is equal to mg is equal to f, right? All of them are equal. You just have to equate actually these two. So t root 2 equals f, and here you have to equate t root 2 equal to mg. Okay, when you equate this, you'll see that all of them are equal, right? T root 2 equals mg equals f, right? So you can simply find one of them and that will be equal to other, right? So we want to find f, so let's find mg. Okay, so mg will be given as m is 10 and g is also 10, so mg is 100. So yeah, 100 is equal to t root 2 is equal to f. So 100 Newton is the correct choice over here. Okay, very simple approach. Just resolve the forces along vertical and horizontal, or along the incline and perpendicular to the incline, and equate them, equate the forces in horizontal, equate the forces in vertical. Okay, and solve the equations, get your answer. Okay, so solve and resolve and solve, that is the idea. Okay, let's get to topic number 2 now. So our second topic is Newton's law, and the one that we are going to see more or discuss over here is the second law. Okay, because the first and the third laws, those two laws are very much conceptual. Okay, so let's come to the question number 1 over here. You can see a ball. Okay, that is a ball which has a mass of 150 grams, which is moving with a velocity of 20 meters per second. And now this ball is hit by a cricketer and it's a catch. Okay, so somebody who catches it within this interval of 0.1 second. Okay, so that is the time he takes in receiving that catch. Okay, so this is the catch time. Okay, you are supposed to tell what is the force exerted by the ball on the hand of that person. Okay, now you are just supposed to apply Newton's second law. What does that say? F equals ma, right? No, that's not Newton's second law. Newton's second law is F equals dp by dt. Okay, F is sometimes not equal to ma. Okay, you can check out my videos on that, but anyways, that's not the topic over here. So F equals dp by dt, the rate of change of momentum. Okay, so if you see, initially the momentum is this, mass times velocity. Finally the ball comes to rest, right? When the person catches it, it comes to rest, right? In his hand, the ball is at rest, the velocity is 0. Okay, so the final momentum is 0 over here. You can see that we can write this dp as final momentum minus initial momentum, and dt as the time interval, right? Here it is 0.1 second. So final momentum, velocity is 0, mass into velocity, that will be 0, right? So velocity is 0, that's why final momentum is 0. Initial momentum, this into this. So 150 grams, convert that into kilograms, so into 10 to the power minus 3 into 20 meters per second upon the fraction of second 0.1. Okay, so here you'll get the value as minus 15 2s are 30, 30, so 1 2 3 zeros, 3 zeros cancels with that, so 3 upon 0.1, so that will be 30. Okay, just basic calculation. So minus 30 newtons, or here you are just asked for the magnitude, minus sign because he of course applies the force. Okay, here I have calculated the force that the person exerts on the ball. Okay, so it is in the opposite sense, right? The ball is in this direction, the force is in the opposite sense, so that's why the sign is negative. Okay, So anyways, okay, let's come to question number 2 now. Here you might call this a question of constraint motion, because you see pulleys over here, the motion of this is dependent on that. But I will say that this is a question of Newton's second law. Okay, now I will give you a short trick for pulley systems over here. Okay, so we'll come to the trick. Here you are given a pulley system, the mass m1 is greater than m2, acceleration of this system is g by 8. Okay, fine. So you are supposed to tell the ratio of m1 is to m2. Okay, m1 is to m2, that ratio you are supposed to compute. Okay, so what can we do over here? Okay, so first of all, we are given the acceleration, so we can exploit that data. We can find the acceleration of the system. Now the longer way of doing this is to write f net for this, f net equals ma, f net equals ma, and then solve those equations and get your answer, right? But I will give you a short trick over here. Acceleration is f net upon the total mass. Okay, this works for pulley systems. Okay, especially the non-movable ones. Okay, you apply to that. Okay, so f net upon m total. Okay, so if you see the net force in this pulley system, here it is m1g, here it will be m2g. You know that m1 is greater than m2, so this force is bigger, right? m1 is greater, so it will pull it down. Tensions here in the string is internal force, so we won't consider this tensions. Okay, they are internal forces. You just have to see at this forces. Okay, so net force, if you see, is m1g minus m2g, right? So if you subtract this force, m1g minus m2g, that will give you the net force, right? And the total mass over here is m1 plus m2. So basically this is the short trick. Acceleration in pulley systems is basically given as f net by m total. Okay, so m1g minus m2g upon m1 plus m2. Okay, so this is the net force, right? And divided by the total mass. Okay, so here you can see that this acceleration is given as g by 8. You just have to solve this now. So m1 minus m2, I'll take g common, and upon m1 plus m2, right? G and g will cancel. m1 plus m2 equals 8 m1, just cross multiplying, minus 8 m2, so 9 m2. Okay, so 9 m2 is equal to 7 m1. So m1 by m2, m1 by m2 is 9 by 7, right? 9 by 7. Yeah, so option B, 9 is to 7, is the correct choice over here. Okay, so this ratio is 9 is to 7. Okay, now you can remember this short trick, that acceleration in a pulley system is basically given as f net by m total, right? So the total net force upon the total masses in the pulley system. Okay, we'll practice more such type of questions in constraint motion. Okay, so let's get to our next topic now. So topic number 3, constraint motion. Okay, so wherein the motion of one depends on the other. Okay, so here you, in question 1, you are given an inclined plane, angle of inclination theta, which is the one that you are supposed to find. Okay, this is a 5 kg mass, this is a 3 kg mass attached by a massless string. Okay, it is given to you that this system is in equilibrium, then you are supposed to find this angle theta. Okay, again, what to do in questions of equilibrium? Now you might call this question of constraint motion or equilibrium composition, right? That is what I said. The topics can be easily mixed up with one another. Okay, so again, actually this is more a question of equilibrium. Okay, anyways, let's do it. So if you see, you just have to resolve and solve, right? So here the force is tension, and here in the downward direction you have mg force, right? So first let's balance the force on this block. Okay, so you will write T equals mg, right? These two forces are equal, this block is not moving. Okay, now in this case here we have normal reaction, and I told you perpendicular to the incline we have mg cos theta. Okay, and along the incline we have mg sin theta. Okay, now these two are balanced by each other, and this tension force is balanced by the mg sine theta component. Okay, now if you see, you can equate this to, now this m stands for mass of this block. Okay, we were writing equation for this block, this equation is for this one, this is for this one. Okay, so I'll write here mass of b and here I'll write mass of a. Okay, now these two tension forces are equal because it is a massless string, right? So you can just equate this, t equals mb by mbg and this one. Okay, so mbg equals mag sine theta, right? So g and g will cancel. This mass of b 3, mass of a 5, so sine theta is 3 by 5. Now you should know this famous triangle. Okay, so this is the triangle 37 degrees. Here we have 3, here we'll have 4, and here we have 5. Okay, and this angle is 53 degrees. Okay, and this is of course 90. Okay, so if you see, sine of 37 is 3 by 5, right? Sine of 37 is 3 by 5. Okay, so this is the famous triangle that you should remember. Okay, so a lot of things to remember today. You are learning a lot of new things, right? So that is the aim of the series. Okay, so yeah, option A, 37 degrees is the correct choice over here. Okay, now let's come to question number 2. We'll solve this one by the shortcut method. Again, this is a constraint motion, simple question, pulley system. These two masses are given to you, and g value is, you are told to take it as 9.8. You are supposed to determine the acceleration of the system. Okay, now you might write equations of this and then solve it, but let's do it by the shortcut approach that I told you, right? Acceleration will be given as f net by the total mass, right? Let's write that, f net by m total, right? If you see, the net force over here is 5g in this direction and 4.8g, right? They are opposing each other, you can see that. So 5g minus 4.8g. Okay, so 5g minus 4.8g, I'll take g common, upon the total mass, so 5 plus 4.8. Okay, so 5 plus 4.8, oh, that's 9.8. This is 0.2, right? And this is 9.8. Again, g is also 9.8. This and this will cancel, and you'll have your answer as option D. Okay, 0.2 meters per second square. Okay, it becomes very simple through the shortcut approach. Again, it can be done by writing equations, f net equals ma for the two blocks, then adding them, solving them. Again, you'll come to this thing only. Okay, so it is a shorthand approach to do this kind of things. Okay, now again, these two blocks are connected by a massless string. Now it is pulled by a force 30 newtons, making an angle 60 degree with the horizontal, as you can see. Okay, you are supposed to tell the acceleration of the system. Now these two blocks are connected by a string. They will have the same acceleration, right? So that is what constraint motion is, same acceleration. Okay, now you are supposed to tell what will be the acceleration. Okay, so first of all, we have to resolve this force. You'll see that only the horizontal force is contributing to the acceleration in the horizontal direction, right? So you are supposed to uh, resolve this force. Okay, so this is 30 newtons, and you'll resolve it. So this angle is 60 degrees. So 30 cos 60, right? 30 into cos 60. So what did I say? It was adjacent to theta is cos theta, and opposite to theta will be sin theta. So 30 sin theta. Okay, so adjacent to theta, sin theta, adjacent to theta is cos theta, opposite to theta is sin theta. Okay, so that is how you resolve if you don't know. Okay, so 30 cos theta. If you see, this one is not needed, we are not concerned about the vertical motion. Okay, there is no vertical motion. This force will be balanced, the force in the vertical direction will be balanced by mg. Okay, so if you see, the only thing that is contributing to the acceleration is the force in the horizontal direction, which is this 30 cos theta. 30 into cos 60, half, so this is half, cos 60 is half, so 30 half 15. Yeah, So 15 newtons is the force in the horizontal direction. Now acceleration can be easily found out using your the net force upon m total. Very simple thing. Net force is 15. The total mass, if you see, 8 plus 7, right? This is a massless string, so 8 plus 7, that is also 15. So 1 meters per second square. Option A, right? So option A is the correct choice over here. And these were the questions on constraint motion. Let's get to the next topic now. I hope this is super simple. Okay. So our next topic is pseudo Fermi force, of course. Okay, so in this question number 1, we have Olivia, who is the central character of our channel. Okay, she is in this lift. Okay, this is a lift, by the way. Okay, her weight in this lift, which is not moving, which is stationary, is 49 newtons. Okay, weight is measured in newtons, mg, it's a force. Okay, and her, you are supposed to tell her weight. Okay, tell her weight when the lift is moving downwards with an acceleration of 5 meters per second square. Okay, so that is the question. Some of you might directly know the formula, that weight in this case will be given as mg minus a, right? But here the idea, this formula comes from pseudo force. Okay, so if you see here in this case, our Olivia is in the non-inertial frame, right? Whenever a frame of reference has some acceleration not equal to 0, right? So that time it is in non-inertial frame. What do you have to do? In that case, you just have to apply a pseudo force. Okay, a force which is opposite in to this direction of acceleration. Okay, you just have to apply a force which will be equal to, suppose the mass of Olivia is m. Okay, mass, not weight. Her mass is m, so forces on her, one is mg in the downward direction, correct, and one is ma. Okay, because she is in the non-inertial frame, she is experiencing this force ma, and this force is opposite to the acceleration, as you can see. Okay, so that is the basic idea of pseudo force. Okay, you just have to apply a force opposite to the direction of acceleration. Okay, where m is of course the mass of your person. Okay, the Olivia over here. Okay, so let's find the weight over here. I won't write this formula here, you can now derive it. Now weight will get the same formula, it will be mg minus ma. Okay, so mg minus ma. Okay, so m you can take common, g minus a, so g will take it as 10. Okay, so 10 minus 5, that will be 5, right? G minus a, 10 minus 5, 5, so 5 times of m. But what is this m? Okay, you can find m using this. Here if you see, the only force on Olivia is mg, right? So here mg equals 49 newtons, right? This lift is not moving, this is the initial condition, right? So mg equals 49 newtons. So you can find m from here, right? So it will be 49 by 10, right? So 4.9 into 5, so what is that? I guess it will be 24. 5 nines are, okay, let us do that. 5 nines are 45. Okay, 5 fours are 20, 24.5. Okay, we took the value of g as 10, so that's why we are getting a bigger value than 24. So it is 24.5. Okay, here you were supposed to take the value of g as 9.8. Okay, that time you will get it as 24. Okay, yeah, so option A, 24, is the correct choice over here. Okay, let's come to question number 2 now. Here you have one more frame of reference. We have a pendulum of mass m, let us suppose. Okay, now when you move this frame with an acceleration of a, this pendulum comes to an angle of theta with respect to your vertical, and in this position it is at equilibrium. Okay, again you have to hear that word. Okay, so yeah, you are supposed to find what is the angle theta over here. Okay, when this mass comes to equilibrium. Okay, so equilibrium, resolve and solve, right? So here you have the mass m, so the force on it is in the downward direction mg, and you have the tension force. Are we missing something? No, we are. Okay, we are missing something. Okay, let's bring Olivia back because it is a non-inertial frame. She will dive into this frame for us. Okay, so she is over here now. Fine. Okay, so now we have to use the pseudo force, right? She is watching from this frame, she is watching from a non-inertial frame, so you have to change this acceleration and give it to this mass, right? So it is mass times acceleration. This is the pseudo force that we are applying, okay? When we are in a non-inertial frame and a frame which has acceleration, we have to take the acceleration, change its direction and give it to the mass, okay, that we are watching. Here we are watching the pendulum, okay? So the force on pendulum will be its mass times this acceleration, mass times this acceleration, direction opposite, okay? So that is the idea. Now we are given that this is in equilibrium. If you see, this angle will be theta. We discussed this in the previous case. It will be this angle, right? So alternate angle, this will be also theta. So you just have to resolve this t. So adjacent to theta, t sin theta, opposite, sorry, t cos theta, adjacent to theta, t cos theta, opposite to theta, t sin theta. Okay, and here you have ma, and in the downward direction you have mg. Okay, now balance the forces. Balance the forces in the horizontal direction. T sin theta equals ma t cos theta. In the vertical direction, t cos theta equals mg. If you take the ratio, t and t will get cancelled, m and m will get cancelled. Sin theta by cos theta, tan theta. Tan theta equals a by g. Tan theta equals a by g. So option C, tan theta equals a by g is the correct choice over here. Okay, this is one more question for homework for you. I think it is also a BITSAT previous year question, so do give it a try. Do tell me the answers in the comment section. Correct answers will receive a heart from me. Yeah, take help of Olivia to do it. Okay, so let me explain you. This is a massless inclined plane. On that you have placed a mass, a block of mass m. Okay, now this inclined plane is given an acceleration of a. Okay, now this, due to this acceleration there is a pseudo force on this, you can imagine that, and due to all of the forces acting on that block, the block comes to an equilibrium. One more time, hear that word. Okay, and if the block comes to equilibrium in this condition, what is the acceleration on this block? Okay, so you might see your answer somewhere over here. Anyways, do comment the answer in the comment section below, and yeah, let's move to the next section now. So our next topic is friction. Here are two questions based on friction. Okay, so let's see the first one. Okay, in the first one we have a block of mass 2 kgs which is placed on a rough horizontal plane. As you can see, it is initially moving with a velocity of 6 meters per second. Now due to the frictional force, it will eventually come to rest, right? And it comes to rest, it stops after 10 seconds. Okay, after 10 seconds from this initial condition, you are supposed to find the coefficient of friction mu, okay, of the surface. Okay, so find mu, or the coefficient of friction in this case. Okay, so first of all, we can find the acceleration. Okay, because let me tell you the thought. Okay, what I'm thinking. Okay, so force, we can write the frictional force as mass into acceleration. For that we need the acceleration, right? So first we'll find acceleration by using v is equal to u plus at, and then we'll find frictional force using mu into n, right? And we'll equate this two, and from here we'll find mu. Okay, so that is the basic idea. So first use v is equal to u plus at, right? Finally your object comes to rest, it stops, final velocity 0, initial velocity 6, acceleration is what we want to find, time taken 10 seconds. Okay, so acceleration is minus 0.6 meters per second square. Okay, minus because it is in the opposite sense to the direction of motion, right? So yeah, so acceleration is minus 0.6, and let's substitute it over here. So our force, frictional force, will be given as 2. Now I'm just considering the magnitude. So mass into acceleration, so 1.2 Newton. Okay, Now your frictional force can be also given as mu into n. Now n will be, in this case, if you see, it's on the horizontal surface, and n will be equal to mg, right? And the normal force is equal to mg in this case. So not always, but in this case it is, okay? So mu into, you'll see over here, y always, n is not equal to mg. Sometimes it can be different, okay? So here you'll get the frictional force formula as mu mg, okay? Mu is what we want to find. Here you can substitute the frictional force 1.2, we want to find. M2g is, we'll take it as 10 only. So if you see, it's 0.6, this divided by 2, 0.6, 0.6 divided by 10, 0.06, okay? So option D, 0.06 is the correct choice over here. Now let's come to question number 2. Now it is a little bit trickier one, a conceptual one, so hear me carefully, okay? So here you have two inclined plane, okay? The distance, this distance of the inclined plane from A to B is D, okay? So they are same inclined plane making an angle of 45 degree. Only difference in this two inclined plane is that one is smooth, other one is rough, okay? So on the smooth one, the time taken for a block of mass m to go from point A to point B. So initially at point A, it begins at rest, okay? So time taken from point A in going from point A to point B is t on inclined plane number 1, okay? And time taken for the same block of mass m to go from point A to point B on inclined plane 2, which is rough, that time is n times of this t, okay? So t2, the time taken on this one, is n times of t, n times this time, okay? So you are supposed to find the coefficient of friction in this case, okay, mu over here, okay? So how will we go about this? Okay, let's try it. I'll wipe this out, okay? First of all, we can write the equations of motion, okay? First of all, okay, we are given the time, so I'll write s is equal to ut plus half at square, okay? For both of them I'll write, okay? Here if you see, the only acceleration acting is mg sine theta, right? Along the incline, it's only mg sine theta, right? Mg cos theta is perpendicular, which is balanced by the normal force, and here only the mg sine theta is responsible for its motion, right? So if you see, g sine theta is the acceleration, right? Yeah, g sine theta is the acceleration along the incline, okay? So if you see, we can write s is equal to ut plus half at square. U, I said initial velocity at a was 0, so u is 0, ut, that term is 0, plus half a. Now this s displacement is d, right? So half acceleration g sine theta, okay? So g sine theta into t square, time taken t, and that is squared, okay? So it will be sine theta, sine of 45 degrees is root 2. So this is what you'll get, okay? So this equation, okay? Now let's write the equation for this one too. If you see, the acceleration in this case will be a little bit different, right? So let's resolve it somewhere, okay? We'll resolve it over here. So along the incline, we have mg sine theta, no problem, okay? Perpendicular to incline, mg cos theta, right? Now this is rough, so there will be frictional force which will be along this direction, right, opposing the motion, okay? So this is the frictional force, which is given as mu into n, right? So, and here we have our normal reaction, right? We'll call this kinetic friction to be specific. So this kinetic friction is given as mu times n, right? And if you see now, n equals mg cos theta, right? Right, n equals mg cos theta. There is no motion in the vertical direction, right? There is no motion perpendicular to the incline. The only motion happening is along the incline, right? So n and mg cos theta are equal. These two are not equal. That's why motion is happening, okay? Now I said that n equals mg cos theta, right? So from there you can write the kinetic friction as mu into mg cos theta. This is why n the n is not always equal to mg. Okay, you can study the case of a block on an inclined plane. Okay, anyways, this is the frictional force. Okay, fine. Now what will be the acceleration due to the frictional force? Okay, so if you see, I can write this as mass into acceleration, right? And you'll have mass mu g cos theta. This and this will get cancelled. So acceleration due to frictional force is mu g cos theta, and this is in this direction, right? Friction is opposing, right? So here we have this acceleration is mu g cos theta. I'm just writing the accelerations now because I want acceleration, right? Ut plus half at square. So again, the displacement in the second case is also d. The initial velocity is 0, half acceleration g sin theta minus mu g cos theta, g sin theta minus mu g cos theta. So g sin theta minus mu g cos theta. Okay, so if you see, the angle is 45, so sin 45 1 upon root 2, cos 45 1 upon root 2. Okay, so you can take root 2 common and g also common, and you'll be left with 1 minus mu, right? 1 minus mu. And the time taken for this journey, now half a t square, right? N times t square. This is the time taken. So n square t square. Now if you see, the displacements are equal, so you just have to equate them. If you see g by 2 root 2, that will get cancelled, t square will get cancelled. So here you'll have 1, everything gets cancelled, 1 equals, this thing gets cancelled, this thing gets cancelled, 1 minus mu into n square. Right, now the answer will be very evident from here. It will be, what is that, 1 by n square. So mu is equal to 1 minus, just rearrange and get the answer. I guess this is the correct answer, so just check it. Okay, option B, mu equals 1 minus 1 upon n square is the correct choice over here. Okay, we just found out the acceleration using the by resolving the forces. Okay, we found out the acceleration, used s is equal to ut plus half a t square in both the cases, equated the two displacement because the displacements are the same. Okay, and then we were able to find the relation for mu and the relation between mu and n. Okay, so such type of questions from friction, some very straightforward, some subtle use of your concepts. Okay, so let's move to the last topic. By the way, there is one more topic from friction which is very important from BITSAT point of view, which is block over block. That is what I said in the beginning, right? Block over block are favorite questions of BITSAT, right? So on that, actually I had prepared today, but I think I need to do a separate video on that because explaining that too requires a lot of patience. Okay, and some of you might not understand it that well, so let's make a different video especially for block over block questions. Okay, the concept capsule video will be uploaded next week for block over block questions for BITSAT. Okay, so that is what that puts the topic of friction to an end. Let's move to our next topic. So the last topic and the final question for the day. Okay, so let's get to it and let's complete this video. So here you are supposed to find the maximum velocity with which you can traverse a curve, a circular curve of radius 150 meters without skidding. Okay, and the coefficient of friction is given as 0.6. Okay, very simple question, very straightforward question. Okay, here you are just supposed to apply a formula that says V max in this case is given as under root mu rg. Okay, by the way, I've provided all the formulas of 11th standard and 12th standard in PDF format, so you can check out the links for that in the description box of this video. The links will guide you to another video, and in the description box of that video you'll have the links. Okay, so I know it's a bit annoying, but yeah, do check it out if you want to have a look at all the formulas from 11th standard and 12th standard. Okay, so now let's find it out. So under root mu is 0.6, r is 150, g is 10. Okay, so 0.6 into 10, 6, 6 into 15, 15, 90, 90, and one more 0, 900, under root 930 meters per second. Okay. So option B, 30 meters per second, is the correct choice over here. And yeah, that is pretty much it for today's video. I hope you enjoyed it. If you did enjoy it, smash like and do smash subscribe, because we are very much close to 200 subscribers. Okay, so do smash that target, and I'll see you soon in the next video. And as I said, the next video will be on block over block systems. So see you then. Till then, keep enjoying physics.